All right, so it's show and tell time. Lots of progress. This is the design of the seconds and minutes counter, and so it has all the wiring on top of it. These are the counters, and there's some control logic and the drivers for the Nixie tubes, which I talked about when I showed the diagram of the Nixie tube, high voltage power supply, transistors, and so forth. That's what all this stuff is. And then I have some connectorization on the bottom. So this is control signals, and then this is the actual, goes to the actual display. And then on this page, this is a reverse image of the solder traces, as I showed on the prototype board. A lot of the wiring is actually in solder blobs on the back. And so when I finished this, I kind of didn't like the flimsiness of the wire wrap, and the wire wrap terminals were kind of fiddly to put on there, and I was worried about, breaking these connections because they're kind of fragile. And then, this clocking logic for testing takes up a lot of space. I didn't want to put that on every single board. So I thought about how to actually do this, and I'll show you the result. This is the board, and so this is the production version, and then I have a clock generator here. But basically, these are the counters, so it's 0 through 9, and then it's the 10s 0 through 5. There's a 1's clock generator, 1's reset, 1's preset, then there's the 10's clock generator, 10's reset, 10's preset, then the Nixie tube display. This is the high voltage power supply. I have it wrapped and capped on tape. Also on the back, it's the same. The only thing that comes in, I have the power coming in on the bottom, and I have a clock and a reset line. And so I have the clock on here, and then I have a reset, so I can hit a button and it resets. And then this is all the transistors driving the Nixie tube. This connector over here will be for the colons. And so I can just fire it up by putting it on a, the 1 hertz spot on the board, and you can see it counting on the Nixie tube. And I did a design, again, I'm glad I'm documenting all this stuff. I did a design of that cable. This is the connector pinout and how it hooks up to the Nixie tubes, and it's designed to be, these are mounted in a panel, and then the connector, the wiring goes down on the bottom, and it swoops around to this. So you can see this counting, chugging along. You can see the 2 phases for the 1's going, and as it gets to 9, you'll see the phases of the 10's go. And I can reset this by hitting the reset button. It goes back to 0. And on this connector, it's the clock, it's the reset, then it's the clock out. That's the carry to the next stage. So if this is the seconds counter, that would clock the minutes. If it's the minutes counter, it would clock the hours. And these are all logic levels going through transistors, so an Arduino or so forth can clock those. This was a lot of work. I spent 4 days building this, 5 or 6 hours a day. A lot of it was figuring out my process. I did 1 row or 2 rows, and hooked it up to another circuit, ran it, and once I sort of saw that it worked, I was able to just sort of go an assembly line and do all of them. So on the next board, we have to do 1 more of these for the minutes, and then a modified version of this for the hours. I'll be able to go faster, and I realized I needed more space, here and here, because the wiring got really, really tight. And for the hours, there's more logic. There's 6 more relays which might go here. I can maybe compact this a little bit better, but it's a good learning thing. One thing that really saved me, was having diagonal or bent long nose pliers, because you can get in and insert wires. And then the real key was the wire stripper. This is a automatic wire stripper. It does like what 32 all the way down to 7 gauge wire. And the advantage of it because it has a little fence there. Instead of using the wire stripper where you have to yank on it, you just sort of insert it and you pull, and it makes the strips the wire. It's the same length every time, and it doesn't require any force on this side. So you can, so if you're working in here, when you're stripping the wire, if you're trying to get the length just right, you don't have to worry about pulling it like you would on a normal wire stripper. So this thing was great, and it's really fast. You can just go there and just click them off. So it's counting away. I have a little power switch where I can turn off the power. I can reset the count, and since this is my clock generator, I can make it run. I can make it run faster, like so. And I can go faster, and then there's even that's ludicrous speed is a little bit too fast for it. There you go, ludicrous speed, and you can see it just cycling through nice and fast. You can see the ones counting, and then it rolling over. You can see how fast the tens clock is going. So it's been really, really robust. I was really surprised that, you know, when I put in each one of these wires, I have to put the wires in, flip it over, take it to the soldering table, solder it, take it back, put in a wire. So this has been handled a lot, and I was worried that the relays would, or some wire would come loose, or the relays would have an issue. But it's been rock solid. I'm really happy, and that was a concern I had with handling for these wire wrap things, because if you yank too hard, you know, these might break, or they'll come loose, and then it's a disaster to fix. The one thing that was difficult was getting the wires down into some of these spots, and I was good at, you know, getting my technique on debugging. I should make this not so obnoxious. I was good at my technique of you know, debug. You know, like having the lights, and then when the light wouldn't work, you know, it's usually because I forgot, you know, just some solder connection. And if you look at the back of the board, you can see it's just a maze of solder connections, and, you know, all it takes is, you know, leaving off one. And these blue wires aren't blue wires. It's actually, it moves the clock around. Those aren't mistakes. Anyway, so happy with the results. I have to do, like I said, another one of these, just like it, and then the hours, and then I'll be able to assemble this and start thinking about you know, the chassis and the control panel. So then, you know, there'll be standoffs on the four corners of the board, so they'll stack up. That's why the connector is coming out the side, and the front panel will be here for the, you know, seconds, hours, and minutes. So it's been a lot of fun, a lot of work. You know, it's engineering. Love it. Anyway, so to have an update, maybe I'll take a break and, you know, work on the minutes next week. All right. Thanks for listening. Bye.